Hello, today we are going to solve problems using the concept of mole. This concept is key to calculations in chemistry, so it is very important to understand the relationship between this concept and the concepts that are also used in problems. So, I suggest that we solve the following problem today. It consists of several parts. Under the conditions of our problem, we are given a mass. Very important, sulfuric acid. It is one of the leading substances in chemistry, produced in large quantities. This huge amount of sulfuric acid is used by society. Further, the second question, we are given the amount of carbon dioxide. And this substance is also important because it is a product of our life activity. It is in the atmosphere. Part of the problems are connected with this substance, including the greenhouse effect. In addition to this, the number of particles of the substance ammonia is also known. Ammonia is also an important compound. The production of this substance is engaged in chemists in order to obtain from it, for example, ammonium salts, which are fertilizers. So the question in this case is the same. We need to find, taking into account the questions proposed to us, to find the number of moles of each of these substances. So how are we going to solve it? First of all, let's remind you that we have all these concepts associated with moles, mass, volume, and quantity of matter. And last lesson, I showed you very convenient formulas that allow us to derive these concepts through the triangular formula. So, for example, there is a formula that relates mass and quantity of matter. This formula includes the quantity of matter. It's denoted by the little letter n. And also mass. It's labeled by the little letter m. Molar mass. So in this case, let's see. According to the condition of our first problem, we are given the mass and we need to find the amount of substance. So to find the amount of sulfuric acid, let's convert that from our formula. And we can see that to do that, we need to divide the mass by the paint mass. So let's do the substitution. So the mass is 196 grams. But we can find the molar mass of sulfuric acid using the periodic table. To do this, for hydrogen, we multiply 1 by 2, for sulfur 32, and for oxygen, respectively, 16 times 4. All this will be in grams per mole. In this case, we have the figure obtained from below equal to 98. And then respectively grams and grams will be reduced. 196.98 will be reduced to, and then the answer to the problem will be 2 moles of the given substance. We have solved this problem. As you can see, it was not difficult at all. Next, we need to find the amount of substance for the proposed volume. Let's see how the formula works in this case. What we have here is a formula that includes volume, the molar volume and the amount of matter, and since the conditions are normal, that is, at a certain pressure temperature, the molar volume is a constant. So how do we find the moles for carbon dioxide? For this purpose works the formula V, referred to Vm. Let's make a numerical substitution. The volume is equal to 44 and 8 by the condition of the problem in the liters, but the molar volume should not be counted. It is a constant value which should be remembered, 22 and 4 liters with respect to moles. Thus it turns out that in this case we will also have 2 moles. Okay, the next step. We need to find how many moles there are in the number of particles. So let's recall another formula that allows us to do this calculation as well. To do this, we divide N divided by Na. Na is the avogadratic constant, and the little letter n is the number of moles. So we need to find the mole number for ammonia in this case. So it turns out the formula works. N is the number of particles divided by the Avogadro number. Let's do a numerical substitution. In this case, we have the number of particles 1204 multiplied by 10 to the 23rd power, and the number of avogadrons is a quantity to be remembered, and it is 602 multiplied by 10 to the 23rd power, and the dimension of this number is mole minus 1, that is 1 divided by a mole. If we do the reduction, and in this case we can see that the ratio in this order we get to mole. See, in this case I've chosen the conditions of the problem to show you that, for example, for sulfuric acid, for carbon dioxide, and for ammonia, whatever units of measurement we show these data in, they're equal in quantity in this case. And so these answers are our answers to the problem in the case of sulfuric acid, and in the case of carbon dioxide, and in the case of ammonia. This problem is solved in this way. And pay attention that these formulas work, which allow you to find such answers quickly enough, but they must be well memorized so that you do not have to remember whether this formula looks like this or something else. So I advise you very much to memorize these formulas and visually, a few times perhaps prescribe, and then you will solve such problems very, very easily. Well, that's all for today. Thank you all and goodbye.